Having said that, we are going to start with the first session of the day. I would like to invite on stage Wojciech from Amazon. And
I think he's
here.
Second time.
Yeah, actually the third time in Cluj.
No, but for the developers, it's the second time.
Yes, the second time at the developers.
And it's kind of tradition to have Wojciech starting the event, which is great.
Yeah, it's a good tradition to, you know.
And before starting, I like to remind everyone that we have also a contest, and yeah, we will see, and there will be a party at the end. So enjoy.
Yeah, that's going to be interesting.
Yeah.
Maybe in a break you can tell us a bit more about that. And as we're going to welcome Wojciech on the stage, I cannot help it, Wojciech, so forgive me, but I need to bring up the latest and the brightest news about Amazon technologies. And I'm sure those of you that have been following, I don't know, different podcasts, web bloggers, and I don't know, TikTokers and things like that, have heard about or have read the article that I think Amazon Prime developers published at some point, describing how they gave up on serverless and went to monolith. And everybody was like, oh, microservices is crap, serverless is crap, everybody's going back to monolith. Even Amazon, who invented that kind of stuff, is throwing that away. But that was all a misunderstanding, because ultimately what those developers tried to convey to the readers was to present how they were able to evolve their architecture and not to be afraid to give up on things that make no sense. So having said that...
One more thing.
Yes.
I just heard that Amazon has opened an office in Cluj, which is great. And yeah, welcome.
Great to know that. Okay, so having said that, I'm really hoping that today's talk will put some light on how we can still do that, but maybe do it from the beginning, or maybe take the right decisions a bit earlier in the process. Not that that whole article was not a good learning opportunity, but maybe there is more to it. So, Wojciech, the stage is yours. Thank you.
Thank you very much. That's actually a great introduction and then starting point about this article. I knew that it will be coming, and I knew this will be a topic. And I'm glad that you said that this was a journey explained, because if I will tell you that, probably this will sound like a preaching, maybe something that it's not authentic. And essentially, the talk that is currently rolling is actually about the journey and making those decisions in the best way, and also how is the role of the architect looking in that whole picture, because this is one of the things that is often overlooked, or rather driven by some decisions that are not entirely guided and not entirely argumented properly. I was introduced already. I will just tell you that I'm also working for Central and Eastern Europe. So if you are a customer of AWS, Amazon Web Services, or you are AWS community member, for example, AWS Community Builder, AWS Hero, let me know. I will be happy to talk to you after that talk. Essentially, the role of developer advocates is to listen to the community, not only AWS community, but in general, community, listen, hear the feedback, and also raise it internally, and vice versa, to communicate what its company going to tell you and what we are actually offering. But before I started my journey as a developer advocate, I was a software engineer, cloud architect, and also operations engineer. Not in that order, obviously, but throughout my career, I actually started doing stuff as the operations engineer, maintained a lot of stuff. Then I moved to more developer-oriented roles, also related to quality assurance, and then I moved to the architecture roles. And I think that perspective across the almost whole software development lifecycle gives me a little bit of mandate to actually tell you a story about journeys that we are having inside IT, when we are creating actually IT solutions. So I would like to start with a tale about this startup. You probably heard this numerous times from numerous speakers, also from people from the AWS as well, probably. It's usually a business idea, a revolutionary business idea that every startup has, or every business has. They want to build something very quickly, they want to validate that, then they start to catching traction, they are growing, they want to build something much better. Then there is a validation period regarding the ability to crossing the chasm, the way that they will either go mainstream and be able to appeal to the majority, or they will actually die in that chasm when it comes to the other businesses. And then there will be obviously moving into more optimized role. This is not something specific to IT, this is a regular economic evolution of every single business. But in that particular tale, usually when it comes to the tech companies and startups, everything is related with the technology, and majority of the important decisions that are made are actually related with the technology side. So obviously we will start with this. What kind of impact those decisions are having, and we will also look from that perspective onto the journey, the whole evolution of the startup. So as I told you, it always starts with a revolutionary business idea. Let's assume that owners and actually originators of that idea do not have a lot of knowledge about cloud computing. They rarely used anything beyond the regular servers, but they want to build a business, they have a revolutionary business idea. Obviously, they can start with a three-tier web application, or designing something that will be along the lines. If I will have some kind of client on the picture that is available behind me, probably this will look to you as a classic web application that has 3 tiers. I skipped that part because this particular business is oriented about providing API to the developers. So they cut the corners and actually provide just the API. Obviously, they will have some landing pages, they will have all other stuff, but this will be managed by the CMS, but by the other guys. They are doing the hardcore tech API-driven thing. Obviously, outside of the compute environment that will be hosting their API, they will have some additional supporting elements, including the database. They chose, in this particular case, a NoSQL database because the CTO is a very opinionated person and doesn't like SQL, and they choose DynamoDB in this particular case. Additionally, they are integrating with multiple downstreams, including a third-party APIs that is providing some kind of currency exchange rate. I haven't told you what is this revolutionary business idea, but in this particular case, it actually doesn't matter a lot because this journey will be actually very repeatable and applicable in many cases. But this particular startup decided to do a fantasy NFT token-based stock exchange when they would like to sell their tokens. And they would like to do another layer of that when it comes to the exchanging with the multiple currencies because they want to go globally, they want to do a lot of the development to multiple countries and provide their services to multiple countries. So they would like to provide an ability to actually sell their goods throughout the stock exchange without multiple currencies. Hence, the downstream dependencies with the third-party API. And this particular phase is actually focused on business validation. So they want to test as soon as possible, as quickly as possible, if that business idea makes sense. They would like to do a lot of the validation because they don't want to invest upfront. They will have scarce resources at the beginning, and they would obviously would like to get a lot of traction when it comes to the idea, and then gaining funds, gaining more recognition, and being more recognized. This is a very typical start for many businesses. Then there's obviously a second phase. They gain traction. Everything starts to roll up, everything starts to scale up. They need to be prepared for something bigger. Obviously, a single virtual machine that they used in the past for the business validation will not fit their needs. They need to scale up, they need to build more. So that's why they actually decided to invest time to do the proper high availability and resilience, still in a more, I would call it, a more classic way, but very effective, very pragmatic. They are investing into having multiple availability zones in order to support high availability. They are investing into having different services. Maybe they are already starting doing some investments when it comes to the pipeline and software delivery lifecycle. For example, you see on this slide AWS Fargate, which is a managed service for hosting containers on AWS. If we are hosting containers, we need to actually build the images. So they need to actually build a pipeline to handle that as well. Again, this is a very typical step that it's identified on the journey, especially if the original validation period is actually finished with a success. They see an attraction, they see a need, so they want to go further. Then there is this third step. And this is actually the trouble period for many businesses. A lot of business requirements changing, a lot of friction when it comes to the original technical debt, and additional new things that are appearing on the horizon are actually building up the whole issue with evolving the whole architecture and whole software. In this particular case, you can see that they decided to onboard partners to the platform, and they built another way of providing their service throughout some batching requests. So they are actually involving another server, another way of interacting with the server throughout the queues, and then with those queues, they are actually having used exactly the same compute platform that they are using. So again, from the architecture perspective, it looks like something that it should be easy to introduce, but devil is in the details. Everything depends on how they build originally the whole platform and how easy it will be to expand, to evolve, to maintain. And then there is obviously a fourth part. When the troublesome period ends and the business is still thriving, they want to optimize. They want to increase their margins as much as possible. They want to be as scalable as possible. They want to respond to the demand. They want to do a lot of the decisions that they couldn't do in the past much easier now. And the whole point of having an evolutionary architecture in their case would be to actually enter this particular step without troubles and then focus on optimization, on continuous improvement. I will do the transition once again. So this is step number 3. This is the step number 4. There's not a lot of changes on that slide, but 2 major ones are actually replaced: the API layer and the compute layer. Some of you who actually participate in the software development lifecycle, I assume all of you, are actually suspicious about how easy that transition would be, because everything will depend on how complicated the whole pipeline and whole structure will be. If there's a lot of technical debt, it wouldn't be as easy as switching from slide 1 to slide 2. Definitely there will be some refactoring, reorganization, re-architecture going on. All of those 4 phases are actually very typical thing, but at the same time, how easy will be going from step 1 to step 4 will be dependent on how good the architecture will be. So let's talk about architecture, and let's talk about what is the responsibility of software architect to actually tackle those challenges. Can you shout out what is the job of the software architect in the project, in the IT project? Shout out to me. What is the main responsibility of the software architect?
Have overview over the app.
Yeah, have overview over the app. Thank you, that's a good one. What's another one? Anything else? Just an overview? Design. Yeah, that's another one. What else? Ask the hard questions. I like this. This is also a good one. Yeah, what's next?
Yeah, I wanted to say they also have to plan the next steps and to always know what the other teams are working on, like to have a brief idea so he can plan further or they can plan further.
Planning the next steps and having an idea what are the next steps planned by the other teams as well. Yeah. You see that I asked a lot of you and I received very different responses, and leaving this as a joke, you can say that the job of the software architect is to architect. But what does it mean, really? Even if the big organization has an architect role defined, they are having sometimes multiple ladders of those architects. Like, there is the solution architect, there is the software architect, there is even a big boss called enterprise architect at the end of that ladder. What does it mean to actually be a software architect, and what kind of decisions they need to make? And also, what is their impact? Because the impact is one of the things that it's very easy to overlook from the business perspective, especially if you will focus just on the technicalities. Let's talk about definitions first. Yeah? What is the software architecture? Software systems architecture. This is a definition from a very old book, very good one, and it focuses on having defined interconnectivity and relations between multiple components in the system. If you will look into the more work, for example, into system thinking, into additional elements related with the software architecture patterns, you will see a lot of similarities when it comes to that definition. More or less, we are talking about connectivity, interdependence between the components, and how those relations behave. If you will think about those relations between the components, you will actually see the essential system properties and traits that the system has. For example, if we need to do an integration with another system throughout our database, yeah, this is not the best pattern, but it's a very visual one. If I will tell you that we are integrating between systems through the database, you already have a mental model in your head that you need to do a particular set of trade-offs to actually use that kind of integration and use it effectively. If I will tell you that we are using publish-subscribe, we are using some kind of event bus in the middle, you will also have a mental model and visualization about how you will interact with those systems and how they will actually interact. Having this mental model, you will know that, for example, majority of the communication in that particular integration model will go asynchronous because you are using event bus, there is some publish moment, and there is a subscribe moment when you are receiving those messages. Maybe there is a filtering in the middle. You are just subscribed on those messages that are interesting for your service. So defining those relationships and interconnectivity actually defines how those systems work, and this influences non-functional requirements. Obviously, the functional requirements as well, but the non-functional requirements are often one of the things that are not exactly well understood and well defined. Having both non-functional and functional requirements defined, we can already talk with the business. We can already talk with them about what are the most important elements inside, what we should focus about, and what we should do about when it comes to the evolution, the next steps, what are the plans for future. Another job, or rather viewpoint of the architect, is to being able to see multiple dimensions. And by dimensions, I'm not only talking about this visualization that in the team there is also a dispute going on in many cases. Framework A is better than B, we need to go with this framework, or we need to go with microservices because monolith sucks, or we need to go to monoliths because Amazon ditched the microservices. Modern architects should see multiple dimensions. And by multiple dimensions, I mean here that they should value and evaluate the trade-offs. Trade-offs is not something that you should avoid. You should actually work with that, like with the risk management. If you are working with infrastructure security or security in general, you know that you cannot protect from all kinds of risks that are outside. You cannot eliminate the risk. At the end, you will prepare a risk management strategy, and you will classify those risks as this is the most probable one, this is the least probable one, and then you will apply prioritization. It's exactly in the same way when you are deciding about technological decisions. You need to think about them, you need to work with them, and then decide and prioritize what is most likely, what is least likely. And those dimensions are actually very important because they are driving further decisions and further discussions. If you think about this particular example, when one option is fighting with another option in the team, the role of the architect is actually to evaluate both and then suggest in the most informed and argumented way that we should go with one or another. But it should be argumented, it should be evaluated, and it should be contextual, because all of those choices are contextual. Another point, what architects should do is to evaluate those decisions with having a little bit of grain of salt and knowing that not all, or rather non-decisions are just black or white. There is a multitude of shades of gray between them. And this is also related with such decisions like the architecture or technological choices. Even if you will see a great architecture pattern, a great service, anything else, even if you will see them, they will fit perfectly your use case. There is always something that will not be appropriate for you. It can be a very small thing, it can be a big thing, but eventually it will be defined as a trade-off for you. Again, you will need to classify those, you need to apply the probability, and you will need to decide between those shades of gray properly. All of those options are not free, and this is one of the things that it's usually advised by people that are selling the snake oil. This will solve all your problems. Only microservice architecture is suitable for you. Ditch the monoliths. Use always monoliths. All of those options are not free, and they are not actually providing you something that will be uniformly understood and uniformly applicable. For example, if you will decide to go microservices first, and you will skip the monolith phase, it may be perfectly applicable to you, but you are starting with a distributed system from the get-go. Is that something you want to do? Do you have operational skills to maintain distributed systems in your team? Do you have the team size that will be managing those infrastructures? Are you able to scale it properly? Additional complexity, effort put in, or underutilization in other areas that will actually be compromised because you chose some of that stuff. Those are trade-offs and those are consequences of your choices, technological choices that you will have. And again, as a modern architect, we should sell the options with all the trade-offs included and presented. And again, we shouldn't tell that there is a choice that will solve all your problems because it's never true. Another way how modern architects are actually working and tackling this complexity is that they're zooming in and zooming out. When I'm looking at this animation, I can feel that it's a little bit trippy, but essentially, this is how the architecture and software architecture looks like, or actually how those diagrams should work. If you will think about it, those architects that are working on a very high level, they should see a very high organizational level. They will see something like a globe or something like a map of the world. Then when they need to go into details, they can zoom in into individual continents, countries, even cities to see the exactly details. Handling the complexity, zooming in and zooming out is actually a way to handle the complexity because that's how our brains work. That's how we are visualizing the stuff, that's how we are using mental models. And we should be able to move from a very high level as the modern architects and go very dive deep into the details and being able to talk with those who are implementing even the low-level details. This is one of the concepts that I really like when it comes to defining the job and also the qualities of software architects. As an architect, you need to be able to write a software architecture elevator, and you need to be able to work with the people in the engine room at the bottom, below the ground floor even. But at the same time, if you will be joining that elevator and you will be rising up to the top, to the penthouse when there is an executive team waiting for an update, you should be able to talk with them as well. So this is a way how you can measure impact. If you will be able to talk with those at the bottom and at the top, you will be very impactful in your role. It means that you will have an overview, something that already was told by the audience, that architects should have an overview of the system that we are building. And ability to how quickly you can move between those floors is actually a unified way how you can measure impact. Again, how many levels you can span and how many levels you will be fluent to talk with. I told you that I value this concept, and I took it from a great book written by Gregor Hochbe, my distinguished colleague. And he defined the software architect elevator as one of the things that you can see on the slide. So you need to talk with the business about strategy, connect it with IT strategy as well, because you will be one of the people that will influence that strategy together with the old technical director and department. Then you need to learn about how to apply the change, how the change is done. You need to conquer complexity. You need to think about how to explain it, how to demystify, excite people about stuff, and sometimes how to avoid sensationalism, because that's often very visible in our industry, that people are very eager to jump on some trains very quickly. But at the same time, you need to have technical knowledge as well. You need to be able to design scalable systems. You need to be able to remove friction, to work with technical depth, to think how to keep up, how to talk with those technical teams properly. If you will have both very soft skills and very hard skills, you will be very successful and impactful in your role. Modern architects should connect the dots. If you will think about it, we know about all the best practices, all the patterns that we learned either in our previous steps in the journey in IT or just by keeping up. So like stuff like how to do automated deployments, how to do observability, how to maintain velocity when it comes to evolutionary architectures and evolutionary systems. Then we will have the set of non-functional requirements. They are rather non-changeable ones. They are very well defined. If you will think about it, if you will look to the sources, you will see a very good classifications. And then having knowledge about the patterns and then about functional and non-functional requirements, we can connect the dots. We can apply certain techniques, certain tools, certain elements that we learned throughout our journeys to actually connect those and effectively use. By with applying a pattern, we can solve some of the challenges related to particular functional or non-functional requirement. And one of the things that is important in the role of the architect is also being able to identify the trade-offs that could break constraints. And this sounds like something that is a myth or a legend, but in many cases, and many people will tell you, if you will go fast, you need to sacrifice quality. If you will want to innovate, you need to sacrifice standards. If you would like to customize, it won't be cheap. If you want to go with the long-term gains, you need to be slow at the beginning. Well, that's one of the things that are called that are actually very deep when you hear them at the first time. But at the same time, especially if you are longer in the industry, you saw situations when you were able to bridge the world of those two seemingly unrelated concepts, apply something, and then realize that there is a value and immediate feedback going on. Obviously, it will have trade-offs, but they will not be as visible, as painful as it may sound. So your job as a software architect will be to identify those places when you can actually gain both things, and then evaluate that from the perspective of having a trade-off. And I really like that we started the discussion with the article that was written by one of the Amazon Prime teams, because that was essentially an example how they choose to have speed and scalability in certain areas, but then the demand outgrown their actual implementation. And they decided, yeah, we need to step back, we need to re-architect, and we need to move to something different. And it's not that they discovered that constraint in the process. They knew it from the beginning that they are building something that will be stateful, that will be handling particular state management. But at the same time, they decided they need to move fast. They need to deliver something fast with a nice quality, and that will be scalable for the first phase. And they did it. Eventually, they had to step back because, as I said, the demand outgrown their implementation. But that's the evolution. That's the consequence of the evolution and approaching the evolutionary thing. Some people read this as the unappealing case for microservices or even for serverless. And the truth is that it is kind of a sensationalism to interpret it this way, because every single case when other teams started with the monolith and then ditched it could be interpreted as a sensationalism towards microservices. It's always a decision. It's always a decision framework that you need to have. And trade-offs will be affecting your journey sooner or later. So to sum up what makes a good software architect, first things first, you need to work like a chef in a good restaurant. You need to be able to identify good ingredients. You need to know how those ingredients are actually interconnecting. And then you need to combine something from those ingredients. You need to be aware of how they affect each other, how they work together, and the knowledge about how well you can compose them, how well you can put them together, is actually one of the things that it's the hardest to learn because it requires experience. And there is no compression algorithm for experience. You need to learn this, in many cases, from the others or the hard way. Bless you. Another one is modern architects should focus on impact. As I told you, we should ride the elevator from the bottom to the top. We should be able to talk with the executives and also with people that are implementing low-level details. Let's call them engine room. How many organizational levels you can span will be directly transferring how much impact you will have in the organization. And we need to know how to talk with both groups and in the middle as well. And last but not least, we should sell options. They are not free. We are not giving them away. We should be honest about research, trade-offs, consequences. There is no free lunch. There is no silver bullet. We know this since the 60s, and we are still making the same mistake as the industry. We are defining something universal, a great frameworks, amazing stuff that will solve our problems, and yet there are proofs, sometimes anecdotal, sometimes research-based, that there is no free lunch, there is no silver bullet. In other words, architects should express intent and capabilities of our systems. And we shouldn't think about products. Products are, how harsh it will sound, an implementational detail. Important one, but an implementational detail. Architecture isn't just a bill of materials. You are the chef, you are responsible for ingredients, you are responsible how the menu look like, you are responsible for the taste, the experience, the overall look of the whole restaurant experience. But at the same time, you are not shopping the groceries. You are controlling the quality of the groceries, but you are not responsible for looking out and shopping. So you should be thinking about what kind of intent you want to make, what are the capabilities of your systems, functional and non-functional one. But essentially, implementation should be delegated somewhere else as well. So let's go back to the pragmatic part, from a tale to practice. Because I talked a lot about the responsibility of the software architect. I told you at the beginning about the journey. So let me put my words into my mouth, and let's see how the practice can look like. Phase 1, validation. How those technical choices and suggestions that we make can be translated to those elements, ingredients that we would like to do. We see on the slide a 3-tier web application. 2-tier maybe if you will skip the clients again. But essentially we are building a classic monolith-oriented web application. What kind of decisions can we make here? Obviously, we need to start with deciding about how to go as fast as possible, how to shorten the time to market, because we want to deliver the results as soon as possible. We want to validate our business idea as soon as possible. So we are having certain decisions made that we need to make very quickly. So we should value prototyping and quick prototyping. We should value something that will appeal to our current knowledge. Remember, at the beginning I told you that team and our owners, the originators, do not have a lot of knowledge about cloud computing. So if I will throw Kubernetes on the slide, probably everybody will be panicking or trying to learn and get up to speed, which will take time, and time to market will be definitely affected. So there should be a pragmatic decision made at the beginning, adhering to what they currently need. And there should be a little bit of opinionation as well. I told you about the NoSQL, that CTO or someone from the technical department is not exactly an enthusiast of SQL. Yeah, let's leave it. Let's focus on a business idea first. We can migrate later. We can do those decisions later because we are just starting. There will be no bad decisions at the moment unless we go fast. So again, we are looking in this step for integration synergy, for something that will allow us to quickly mash up multiple things, deliver something, and focus on validation. Technical qualities, how harsh it will sound, are not the most important in this particular step. That's my opinion, but I think many people will actually agree with this. And I'm not saying that we should skip the technical qualities, because that will actually backfire in the step 2. I'm saying that we should focus on time to market and on the integration synergy, because this will later save us time. So what can be used here? What I would use? For prototyping and quick prototyping, I can use all the services available on AWS. One of the examples is called Whisperer, which is allowing you to leverage the generative AI tools for prototyping your code. If I have Python knowledge or Java knowledge, I can use it to prototype. And in this particular startup, let's assume that they have Python knowledge, so they can actually use this tool. Another one, let's have everything and all decisions in one place. We will use Route 53 for managing domains, for buying the domain, then AWS Certificate Manager to actually handle the SSL and the certificates. Even that we are building something quickly that will be an MVP, we still should have a basic traits available, hence the SSL, hence the TLS, security, and managing this as well. I focused on the Amazon EC2 because this is a virtual machine-oriented service on AWS. And as I told you, team has experience with virtual machines. They used it in the past. They know how to operate. They will be able to quickly deliver on top of that. And then DynamoDB, because that was the preference of the team to use NoSQL. Again, we did those decisions with the trade-off in mind to actually deliver something quickly. Step 2, scaling up. Assuming that everything goes well, there is an interest on the market, we want to build something better. We want to build something that will be scalable for our customers, that will answer when it comes to demand growth, and that will be a little bit finer quality when it comes to technical decisions. So first thing first, we need to decide what kind of changes we will do from the original. Do we ditch the prototype? Should we evolve the prototype? This is one of the decisions that also should be made, and usually it works like evolution. Sometimes it's actually a better way to ditch the walking skeleton and build something from scratch. But still, this should be an argumented and informed decision that we should make. Another point, what kind of things sucks in the previous step for us? Again, lessons learned, maybe a postmortem, maybe some kind of a decision architecture log that we are gathering in the first phase. This should be an input to another one when we are actually improving, because we will note all those elements that will cause pain and friction, and then later solve them. And in this particular case, team actually discovered that the virtual machines, even that they know how to operate them, they are a bit cumbersome when it comes to scaling. So you need to create some kind of auto-scaling groups, you need to create alarms, monitoring this. They don't have time to do that. They want to focus on the business decisions and business functionalities. So they decided to actually move to something more managed. In this particular case, they read something about AWS Fargate, about containers, Docker, images, so they decided to move there. That was a consequence of evolving and actually or choosing one thing at the first step and then evolving to a second. So again, all of those trade-offs that they decided from the day one actually transferred to multiple and other phases. This is a quote from Dr. Werner Vogels, CTO of Amazon, how Amazon was built as the platform from day one. And probably this is one of the reasons why Werner Vogels, as the CTO, is often saying that everything fails from time to time. And this is also a consequence of how the systems are designed at Amazon as well. You need to be prepared for change, and in this particular place, the mantra is the only constant thing is change. So this is one of the consequences how those systems evolve and how they designed. Maybe this will be working for you, maybe you will have different requirements and different viewpoints depending on your needs. Still, in that particular step, team decided that first things first, they need to make cleanup when it comes to configuration management. They need to do a cleanup when it comes to scaling capabilities. They need to think how to elastically move traffic between multiple compute instances because the demand is growing and previous system is not actually responding properly to the growing demand. That set of changes, configuration management, handling scalability, actually introduced another concept to the table. They need to think how to treat their infrastructure as cattle, not pets. something that will be very easy to provision, very easy to evolve when it comes to the provisioning and managing those resources. So they learned about infrastructure as code. If they want to choose infrastructure as code, they learned that they can use AWS CloudFormation or AWS CDK on AWS. As they have the Python knowledge, they decided to use AWS CDK because they are more familiar with the current language. And CloudFormation, at least from their perspective, looked like there is yet another syntax that they have to learn with YAML, all those resources and all those elements. So CDK seems, at least for them, a more appealing choice. Again, a set of trade-offs, but still related to scalability, the current traits that they have in this step. Phase number 3, the most troublesome. Constant evolution of requirements, adhering to changing requirements. Usually here is the place when there is a reflection point about we need to apply a better patterns because we are beyond that step that we are fighting for survival. Now we need to be stable, we need to grow. So they learned that there is an interesting concept called hexagonal architecture, ports and adapters, that allows you to focus on the core of your business logic and then abstract all the dependencies outside. They define that they are having some kind of primary actors and secondary actors in their system. They learned that they can actually abstract away with the code and code qualities, applying proper architectural patterns and design patterns. They can abstract the cloud provider concepts that were spread around the code. So they actually put in an effort, created a lot of additional elements in place, but they were able to abstract and combine everything into this domain logic core. This core has the extension points called ports. Those ports are actually responsible for communicating with outside world. They are essentially defining a set of dependencies that will be implemented with the help of adapters, the last layer. And that last layer, adapters, are actually handling the all specificity regarding the cloud providers. So again, what can be used here? As we are doing refactoring, as we are doing continuous improvement, we need to introduce pipelines, continuous integration, continuous delivery, deployment pipelines. We need to have a process for streamlining changes. That's why they looked for other services that are providing this. One of such service on Amazon is the Code Catalyst that can be used to actually implement CI/CD and pipelines together with their application that is currently deployed there. They focused on refactoring and improving, but at the same time, it doesn't mean that they don't have to introduce new features. So they focused on providing multiple new features. And for example, they use Amazon SQS to actually to provide the needs for introducing batching requests for the partner management system. As they refactor and create new stuff, they created code artifact repositories that will store their reusable libraries, modules, elements that they are extracting from the current state. So for example, the reusable domain logic pieces could be part of those libraries stored somewhere as the immutable infrastructure artifacts. And last but not least, they again used some additional tools that help them to prototype their safety nets. They could use Code Whisperer, for example, to create test cases and test unit tests, integration tests, to actually support their need for having a safety net when they are refactoring. And the last step, optimization. They are finally moving into the direction when there is a need to actually optimize, to cut off the friction, to have the ability to grow, and then to actually leverage the business potential that they have and continuously evolve. And in that phase, they focused on optimization, on cost optimization. So that was one of the things that was actually important for them, because the cost optimization gave them ability to reduce the operational and the total cost of ownership. But at the same time, they focused on other elements for improving the pricing mechanisms, for improving the ability to grow, and then do not expand the costs. They also discovered in the process, when they were growing, that in some cases, they need to react for the downstream failures, because they are integrating third-party services. So they applied even better patterns, like circuit breaker patterns, for example, with the help of the step functions, another service that helps you to create state machines on AWS. They implemented a circuit breaker pattern for a downstream service that was failing on them. And then there are multiple other steps after that, because they will continuously evolve. Maybe they will be not as defined as the previous 4, but there will be a continuous steps throughout their evolution. What will be the next steps for them? Maybe they need to focus on security, because there will be a standard or the audit required. Maybe they will be guided by the local authorities to actually introduce some standards. They will need to focus on security on their side. And this is another set of choices that they will need to make, and another set of tools that they will be able to apply. Maybe they need to think about the cloud governance, because they will grow so fast, they will provide so many partner opportunities, that they will need to isolate them from each other. That will drive the demand to actually create multiple environments, and that will require another set of functionalities regarding the governance. Maybe they will need a growing need for observability and monitoring to actually observe how their platform works, how it looks like. This will probably appear much earlier in the process, but maybe they will need to refine what it's currently having. And last but not least, maybe they need to introduce another level of visualization when it comes to billing and cost optimization. If they are driven by the margin and how great that margin will be when it comes to revenue, maybe this will be their priority to optimize that part. And last but not least, maybe they will apply another set of code and architectural level patterns. For example, command query and responsibility segregation. This is a code level pattern, very frequently presented as the infrastructure pattern, but this is a code level pattern that then can be scaled with the infrastructure choices. Again, it has some trade-offs. It's not always applicable, but maybe in their case, it will make sense to actually introduce it and then support it with another layer of components introduced to the picture. Summing up what we talked about. Once again, as the software architects, we need to focus on integration. We need to think about how to select proper ingredients, how they interact with each other, and more importantly, how composing them together will give you an integration synergy. Another way, and another thing that modern architects should focus is about the impact. How much impact do you have in your organization, and how much impact will you have when it comes to the organization? Can you talk with the people at the engine room, and at the same time, after riding the software architect elevator to the top, can you talk with the executive team? And last but not least, informed, evaluated, and argumented feedback about the options. No free lunch, no silver bullet, just decisions that are not free. This is one of the quotes I really like because it shows how much potential is actually introduced by the cloud providers. And I know this might sound a little bit cliche, but if you think about it, for that presented journey, many of the things that team decided to do was actually enabled by the services available on the cloud provider platform. I used AWS because I know it the best, but this kind of journey will be uniform for all kind of cloud providers. In general, you can say that cloud democratized creation. And even as small teams can achieve a very substantial results when they will focus on delivering business results and delegate the responsibility to cloud providers to actually do the muck, how we call it. So the low-level details and low-level elements that are responsible for which are responsible the teams inside the provider. And again, in this particular case, it shows how certain non-functional and functional requirements could be tackled easily with the help of the provider services. For those of you who look more about that stuff, I can recommend those 4 books. One already was visible previously, but I can definitely recommend Building Evolutionary Architectures and obviously the classic enterprise integration patterns. If you are interested more into building cloud-native applications, definitely look into the cloud strategy. And again, for some of you who actually looked throughout the journey and actually have more experience with the engine room part, you've seen a lot of resemblance when it comes to the other best practices. I told about CQRS, I told about hexagonal architecture or ports and adapters, but we can actually have the other elements as well. And it's good to have those checklists. And one of those checklists is 12-factor applications, or 15-factor applications, as it's called nowadays, in the evolved form. So this is another way to check if you are aligned to the best practices, and something that may suggest you other options, other trade-offs, and things that maybe didn't pop up in your mind in the first place. If you are interested in learning more, here's the slide with the additional parts. If you're interested in creating more event-driven architectures, I can recommend a community-oriented hub called Serverless Land. There are also a few interesting talks about the role of the architect, how to build cloud-native applications as well, from the past re:Invent. And this is everything what I prepared for you. I will be available for Q&A. I will be more than happy to answer all your questions. Last but not least, on the QR code, you will find the survey. Please fill it. I'm a data-driven person. If you will provide me a feedback, I will be more than happy to acknowledge it. And once again, thank you very much, and I'm open for questions.
Thank you very much, Wojciech. Let's see if we have questions from the audience. Yes, we have one there in the back. Can we get a microphone there, maybe? No? Can I get one?
Thank you, Cyprian.
Thank you for that talk. I wanted to ask about how do you make decisions between all the various frameworks and solutions are there in a very concrete level? Because in your talk, it was just Amazon service for X version and just all Amazon, and it felt like an ad for Amazon services and not like a software architect choosing very specifically, hey, for this one, we're choosing frameworks completely outside of Amazon because I run a bunch of tests and I see that this works, I don't know, 20% faster than the other one. How do you make those decisions? And how do you stay up to date with the gazillion frameworks out there, and how you make these choices in an efficient way?
Mm-hmm.
Thank you.
Yeah, so I'm sorry to hear that it sounded like an ad. I didn't mean to. I just use those examples because I know them the best. I'm in that ecosystem since 2015. So I'm like, it's 7 years of build-up when it comes to the knowledge. Answering your question, when it comes to decisions, I'm not always choosing AWS services because that would be insane. I presented those choices because they were the most appealing to me. But at the same time, using your example, if I would have to choose at the moment a CI/CD pipeline, but my team knows a lot and worked a lot with GitHub. Maybe I should look into the GitHub Actions. Maybe I should look into the other elements that are driven, GitHub Enterprise and so on and so on. If my team knows most about Terraform, I will not use infrastructure as code from AWS. I will use Terraform for that. Maybe another elements related to the Terraform ecosystem to manage the whole infrastructure as code. So I would be driven by listening to the teams and what they need and what they have currently. And this is a different story when you are starting and different story when you are having something. We talked about the blog post that was written by the Amazon Prime engineers. And major resonance from the community was that they ditch microservices because that's a pitfall. We shouldn't do it. But at the same time, nobody thought about what this team actually started with, what those teams have in their current architecture. Nobody asked about the decisions that they had at the beginning, and then make a reasoning, okay, so they started with this because they needed to, for example, deliver something fast. So I would listen to the teams, I would listen to their feedback, learn about their skills, and then apply those choices pragmatically. If my team knows the most about AWS, why not use AWS services? If my team knows about different set of services or tools, for example, as I told you, they used in the past GitHub, Terraform, anything else, I would focus on having the pragmatic choice first. The goal of being able to ride the elevator is to listen on multiple floors and learning about the perspectives and learning about their skills on multiple floors. So I wouldn't say that I'm focusing only on the services from one provider. I would rather listen to their feedback and listen what kind of skills they have and then pragmatically apply it. And then second part of your question, how to keep up. Again, I'm still a knowledge hoarder. This is a person that actually reads a lot, watches a lot of videos, consumes a lot of knowledge, but at the same time, what's the point of having all that knowledge base in my head and in my notes when I'm not applying it? So I would be, and I'm constantly moving to something that is called just-in-time learning. And again, this is driven by the feedback, by listening. When I will talk with the people and learn that currently they are having those and those pain points, like in the journey. They started with virtual machines, they started with deploying something to a single instance, and then they learned that this is not available, this is very not resilient, they need to improve. Then I will learn about more and more stuff based on the feedback, based on the discussions. So again, I would rather focus on listening and having that feedback introduced in the first place, and just-in-time learning to how to solve those problems. Obviously, you can learn, again, from the others. That's the best way, because you don't have to make the same mistakes. But you can also learn the hard way, and actually learning from that feedback that you did the hard way is actually even better, because it's the most valuable lesson. I hope this answers. I see the thumbs up. Thank you.
Do we have any other questions from the audience? I feel like jogging a bit this morning, so.
Yeah, thank you, Cyprian.
There you go.
I was curious if you have some real-time applications, real-world applications that somebody built with all those tools and all those phases that you described here.
With all of them, probably not. But at the same time, I work in the very competitive, in the past, before I joined Amazon, I worked in a very competitive industry called AdTech, Advertising Technologies, which is all about performance, all about stuff, and we have everything on AWS. And that was a while ago, but that was a very, very distributed architecture and distributed system. Everything used in virtual machines, because that was a reason for the performance and the optimizations. But we also used other services that were fully managed to actually focus on the different elements. So when it comes to the critical path, we went very low level, very deep into the implementation. And that was actually a very real-time thing. In AdTech, in the programmatic bidding, you have 200 milliseconds to answer the request. 200 milliseconds to answer a request, otherwise it will be lost. So that's not a lot of time to actually make those decisions. And there's a lot of processes underneath that needs to be done in those 200 milliseconds. So the critical path was done on the very, I would say, crude services, if you will think about it, because we will use virtual machines, very classic things, optimization, low-level stuff, tweaking the virtual machines that actually run our code. But at the same time, outside of the critical path, we wanted to focus on something that is fully managed, because we don't want to manage this particular element. We want to save time. We want to focus on the prioritization, put our prioritization on the critical path. So we used managed services, for example, DynamoDB, RDS, and other elements outside of the critical path to save our time. So I also hope that this answers your question.
I just want to add what you just said about the fact that, even in your presentation, it's clear that the architecture is significantly driven by non-functional requirements, right, which we should never ignore. But then at the same time, especially in a large application, non-functional requirements are not the same for all the parts, all the modules, all the areas of the application.
That's
so
true.
That leaves room for quite a lot of exploration.
Yeah, exactly, and that's also the set of trade-offs you can make. Like, there will be a critical path that will be important, for example, from the performance perspective. You need to have the same performance everywhere. That's very true.
Will you think about this from the beginning, or will you leave that for the optimization part?
That's a good question. I would think, so it will depend how critical this will be for the business. Again, I will be business-driven in these decisions. If I will have this critical path from the beginning, because that will be core of my business, maybe we need to put more pressure in the first phases to actually do those phases, do those elements in a more performant way earlier. At the same time, the bigger business will be, the more critical paths there will be in the business. So essentially in the optimization phase, there will be a need to do a lot more optimization than just the critical path or the core critical path that was initially developed. So again, I will be business-driven when it comes to this.
Thank you. Let's see if we have other questions in the audience. It's too early in the morning, not enough coffee yet. I'm sure more questions will come afterwards. I want to take a minute and ask you something about the impact. You had a bit of, you covered this briefly towards the end, the kind of code level decisions like CQRS, event sourcing, event streaming, other kind of almost like design patterns or design styles to implement. How often have you seen teams pivoting at that level? Because switching infrastructure, if the code is clean, if the code is well designed, you can throw it in a Docker container, throw it into a Lambda function or in a virtual machine, right? It's almost simple. But how easy it is to migrate and to evolve the design in a really dynamic context.
And again,
what's your experience with that?
Yeah, exactly. So I wouldn't have any golden rules and anything wise to say in this regard, because it will obviously depend on the context. But to give more experience level answer, I was in few projects when we are actually evolving in a very similar way. We started as the very optimized towards time to market stuff and moved to something that was an optimized business that it's actually tweaking and optimizing in the last phase. And in many cases, all of those decisions that we made earlier, I wouldn't say that they supported the journey, but they did not critically interfere with the journey. And this is the biggest set of learning experiences that I may have, like, or that you can learn throughout the process. Like, we are often skewed towards learning what is the great pattern, what another great architecture style we can do. But in the end, in our industry especially, we are learning how to not do stuff, to not repeat those same mistakes later. And I would say that if you were able to actually identify those critical decisions that were made earlier that interfered with something later, this would be much more helpful for you in the long term. To give a more concrete example, one of the teams actually started with a very monolithic application. That was the event ticketing mechanism, to put it simply. And they started obviously with the monolith. They started with the ability to deploy it as soon as possible to multiple infrastructure as service providers, including cloud. Then they learned about that there are some events that are more popular than the others and they can break everything. So they learned about distributing this, actually learned about CQRS to separate the comment side from the querying side, to actually optimize the whole process. But the whole journey took them like several years to go there. There was a decision at some point made that we cannot go beyond that if we will stick to this original architecture style, because we did so much technical depth, we do have so much technical depth, that we need to do a very informed decision that either we will stick this way and we will crash, and significantly crash, and that will affect the quality of the business, or we will do the re-architecture that was painful and later on benefit from that. And that required a lot of essentially advertising in the very high levels in the company to do this thing properly, to do it in a way that could be done in an informed way and also time-consuming way. So later on, when the team actually reached that journey, they identified that if they wouldn't do more or less three critical choices around the time when they were developing the monolith, one of the choices was actually about choosing a database provider. They identified those three choices as the retrospective from the whole re-architecture. And they said, okay, so if we will avoid those three types of choices, later on we can actually grow much faster and much better. But there is no compression algorithm for experience. They learned it the hard way in their particular context. So again, I don't have anything wise to say outside of, if you learned something from either community or your own experience, do not make those mistakes again, or more widely, all of those decisions have contextual dependence. In their particular case, that was more or less a database provider choice. That was very painful. And that's why they were skewed toward different decisions later. They didn't backfire yet, so that was one of the learnings that they have that was good. Yeah, I hope this very long and winding answer actually helps and answers.
It does. Thank you. We have time for one more question. If not, before we're thanking Wojciech for the great presentation, I want to add my own conclusion to this. Whether it's Amazon or other providers, all these tools are just another set of tools that we can add to the toolbox. And the moment we know them, we can choose when to use them or when to avoid using them. Because if we only know one tool, whether it's a cloud provider or an architecture style or a design pattern, we're always going to try to use that proverbial hammer to hit every nail we see. But the more tools we know, the more exposure we have, the more knowledge we gather, either individual or as teams, it's always helping us to drive the decisions better. So let's thank Wojciech for the great presentation.
Thank you.
Thank you. Pleasure to have you with us, and I'm sure you're going to open next year's the developers as well. And we're going to take a short coffee break because you guys clearly need that we can sure have more questions in the next sessions. So after 15 minutes coffee break, we are going to split the conference in two. This is going to be the main stage where we're going to talk about AI and stuff, and programming is going to be on the secondary stage on the right. So enjoy your coffee, enjoy the break, and see you in 15 minutes.